try to do is we try to make these properties enable us to control light, sound, energy, and heat and radiation. At the top is these patterns that were done at laboratory scale, and by lab scale I mean 1 square millimeter, sometimes a tiny bit bigger, but nothing commercial. But what the laboratory scientists were able to prove in the early part of the 1970s through the mid-20s was that these patterns, when etched onto certain types of materials, could cause radio waves and light and energy and heat and solar energy to behave in a fundamentally different way and provide additional performance that we couldn't get before. So what Metamaterials did about 10 years ago is we started in the business of becoming a design shop for designing materials that would contain these patterns at varying and different sizes and shapes to change the behavior of energy. And what we offer today as an advantage are three. We've over the years developed a suite of AI software and machine learning software that can enable us to develop and design a library of patterns for different applications. We typically can do that in a matter of hours versus the months it used to take, and with usually a computer and a couple engineers. We can also make these at scale now. We were one of the first companies to develop roll-to-roll production. When I say that, think newspaper print. You'll see a picture in a little bit of how this all works. And we're able to produce very large area, high volume nanocomposites. And we're doing that at a cost that makes these highly affordable and enables a large part of the population to take advantage of the production that we're able to provide. What's driving the business for us is a number of mega trends that are really important to take account of. 5G, everyone I believe is aware of, or sometimes often has a 5G telephone. I hate to tell you, but they're not really 5G yet. Most of the world is not broadcasting in the high frequency range that is ultimately going to become 5G. And the reason for that, I'll share in a moment, but basically it's because the signal doesn't get everywhere it's supposed to go as it's broadcast today. What we're able to do with our materials is help that. And the rollout of 5G is going to require and continues to require lots and lots of new materials for antennas and reflectors. The world is moving towards electrification of vehicles, and that's a given. Electric cars are here already, and by the 2030s they will be have replaced internal combustion engines. That's what everyone seems to believe. Well, the changes that's bringing are enormous, and the types of things that are required to make sure that all of the sensors and the battery technology and weight management and such are dealt with, and our materials can help quite a lot in that space. The market pundits are telling us that there's probably an additional $3 trillion of opportunity in other verticals, including advanced materials, Internet of Things, medical, energy, aerospace, automotive. And one of the things that unifies all these themes is that there is a scarcity of certain types of raw materials that are routinely used to address these problems today. Rare earth metals and materials such as indium tin oxide are used all the time. Indium tin oxide is used in pretty much every smartphone cover or lens today. It's very scarce. It's becoming more scarce, and the sources are highly concentrated in Asia. That creates pricing issues and ultimately long-term demand issues. The device market that relies on metamaterials is projected by Lux Research to grow to 10.7 billion by 2030, and that's what's driving our business. We see this as a very large opportunity for us. I said we're a platform technology company, and that's what we are. We are a B2B company that applies our platform to multiple applications, and we are somewhat agnostic as to the applications. Our platform is three major areas. We use a combination of holography, lithography, and wireless sensing to build our applications and our product suite. On the holography side, we use lasers to record holograms into photopolymers, and those photopolymer holograms enable us to do applications like you see. We're able to, for example, provide laser eye protection for airline pilots and defense people by putting special films and filters that are made using our holography technology. We are also in the business, and I'll talk about it a bit more, of augmented reality and smart eyewear, along with head-up displays for automotive and aerospace, and that's all enabled by that portion of our platform. On the lithography side, we have a high volume, very reproducible, high quality rolling mask lithography system that produces a metal mesh that we call nanoweb. It's transparent, virtually invisible, and it's used in a variety of applications that I'll talk to in just a bit. And in our medical space, we tend to rely pretty much on the combination of metamaterial films that are combined with RF and infrared light signals to do imaging and monitoring and sensing of a variety of medical conditions. So let's talk a little bit about the applications that we're focused on today. First and foremost, we're looking at 5G. As I said, 5G has a problem because the highest speed signals need to have line of sight, and that requires the placement of many of these cells that you see on top of the building. The challenge that the industry faces today is when those signals are broadcast, as soon as they hit something solid, be it a tree, a person, a window, a building, a good portion of that signal is not reflected or transmitted into the building. It's just absorbed by the materials of the building, and therefore the strength and power of that signal is diminished quite a lot by the time it reaches its target. What you see going on here is the signal being reflected back to the street, and that's accomplished by using, I don't know if you can see this, but there's a film in the corner here that you can see. It's a fully transparent film that has a nano pattern on it that allows us to reflect that radio signal back and enable the people walking down the street, for example, to have a much stronger signal when they need it. And so you go from, in our world, 2 bars to 5 bars. And it's totally doesn't require any power. It can be applied as a retrofit, or it can be applied as part of a new construction in windows and or building exteriors. On the flip side, if we have a film that reflects the signal, we also have a film that kind of inflects it, because there's a lot of signal loss that doesn't get into the buildings. And if you want the signal to get into your apartment or your office, then you need to help it. And what we have is we can take that same type of film, change the pattern on it, and turn it into, in effect, a transparent antenna that helps pass the 5G signal through the building into the units. And we're working in Japan to start with one very large chemical company called Sekisui, and they're in turn working with both the infrastructure providers that provide those towers that you saw earlier, as well as the largest telecom in Japan. And they're on a standalone basis just for Japan. They've indicated that over a 5 or 6 year period, there's probably 750,000 square meters of film that will be required on an annual basis to satisfy the demand just in that one country. And just for scalers, from an economic standpoint, that film has a retail value of anywhere from $300 to $450 a square meter. And as I'll tell you later, we can make it at quite substantially lower cost than that. The next place we're working is in de-icing, defogging, and LiDAR protection, as well as EMI shielding. As we talked about, ADAS and autonomous vehicles have to rely solely on sensors and cameras. And the challenge that they all face is that in climates where there's a lot of variability in the weather, where there's rain, there's ice, there's snow, as soon as those sensors get clogged or bothered by weather, they no longer work. And the technologies that are available today, namely, they call them wiggle wires, where they can put wires in the glass and heat the glass to defog and de-ice, et cetera. Those actually interfere with the operation of a lot of the sensors, and they basically block the signal in LiDAR, which is light radar. Our metafilm, by adding a very small amount of current to it, can be applied to the sensor and can de-ice it and defog it without interfering with the signal at all. And when you think about how many automobiles there are out there, both current internal combustion type and electrified and ADAS and the number of sensors that they have that are external to the vehicle, that's a very, very large market, and we're very excited about it. So we're working quite heavily in that space as well. We're also, I mentioned, able to use the same nanoweb film to make transparent sensors and 5G antennas. You can probably see there's a small circle here. That's actually a transparent antenna that we've made for cell phones. We can use them. We use the same film to replace indium tin oxide on the surface of cell phones, and especially things like foldable phones where the surfaces are very sensitive to bending constantly and the acute angles that are coming with that. And again, we can do that at very cost-effective ways. I mentioned early on that we are now starting into the business of augmented reality. We have a partnership in place with a German company called Covestro. It's a spin out of Bayer, one of the biggest photopolymer companies in the world. And we last year acquired an array of automated technology to allow us to make lenses for use in augmented reality glass eyewear. The unique differentiator for us is that these lenses can be cast and UV cured. They require very little, if any, energy, no water, no material. And I think the most important part of this is that we're now able to make and satisfy the one key demand that's in the way of AR right now, which is that most of the 50% of the world plus requires prescription lenses. And we are so far the only company that's able to do that without having to make individually ground prescription lenses. We have a library of a couple thousand prescriptions that we can pick on an individual lens by lens basis. And we can, using the process that we follow, we can also embed in those lenses holographic capability, augmented reality capability, data access. And as you can see in the breakdown picture here, we're also able to put waveguides and projectors and Wi-Fi connections and Bluetooth connections and such. So it's a very exciting business for us. It's an emerging business that people have estimated to be anywhere from 2 billion to 20 billion, because no one's really making a big play in it yet, but there's a lot of very top tier Fortune 50 companies making it very clear that this is a really important space for them to play in. We also have an array of medical products. My executive vice president title is tied to that array of products. And since we went public in the spring of this year and raised the money that we raised, we now have the resources we need to pursue these products in an aggressive fashion. And over the next 2 to 3, maybe 4 years, we'll be launching a number of these. We work in areas like MRI, signal enhancement, breast cancer imaging without the need for an ionizing radiation. And we have a very exciting product in development for completely non-invasive monitoring of glucose in the diabetes population. And we also have developed, or are in the process of developing, a molecular biosensor that will enable us to very rapidly in biological fluids detect the molecular fingerprint of up to 60 different molecules. The one we're starting with is COVID-19. And we can do that in the format that you see in a very rapid test that can be done and have results in a minute to a minute and a half. And that has all kinds of possibilities for the medical market going forward. We are a B2B company today. We do not make things directly for the consumer market. And so we work with a number of folks in each of the verticals we've talked about, along with government agencies, and because they tend to provide a fair bit of funding for us as well. From a competitive standpoint, when we started the company, we believed that we were going to be in the semiconductor space. We thought that we would do the design work and that we would go to the semiconductor industry to make the fabrication decision for us and help us do the fabrication. That turned out to be a bad call, because the semiconductor industry, although they can scale it for volume, they can't scale for size. And so a square meter of what we make today made in the semiconductor world would require a great deal of effort, a lot of time, and $100,000 per square meter when we need to be at 10 to 15. So we moved away from the semiconductor space and into the chemical and specialty material space. And what we got there was we gave up the type of performance that we could get from semiconductor fabrication in favor of bulk cost equation that the chemical companies wanted, but they gave up most of the performance that we needed to have. And the same held true with ITO and specialty coatings and some of the more emerging companies in the carbon nanomaterial space and in the metamaterial space. So where we are right now is we are almost a category creating company where we have a platform of technology that I described. We are virtually self-sufficient from a design and manufacturing standpoint, and what we're doing now is investing in growing our capabilities from a manufacturing standpoint in particular. We are very IP focused. We have 250 filed patents, of which 156 are issued today. There are 68 patent families, at least, and 46 have at least one issued patent already. We have 9 registered trademarks. Our IP is designed to be freedom to operate protecting. We're not intending, and we didn't intend this IP to be trading paper. We want to protect the franchises that we're building in each of our verticals, and we want to make sure that we have plenty of time to take full advantage of the processes and methods that we did and developed alongside of our customers. The team is growing. George Palikaris, our CEO, founded the company, as I said, about 10 and a half years ago. He is a PhD in metamaterials. He started his life in high tech, especially in a high-speed antenna company. He's been focused on growing metamaterials since, and he's done a really, really good job. Jonathan Waldron joined the same day I did last year. He's our Chief Technology Officer. He's also the founder of a company called DigiLens, and he left there to come to work with us. Amos Callis is a co-founder, our Chief Science Officer, and Gardner Wade and Scott are filling out the rest of the C-suite for us in the marketing and production area. We also have folks that are worrying about sales and marketing and business development. I want to talk a little bit about our production scale-up model and how it changed in the last 3 or 4 weeks, 5 weeks, because this is a fundamental shift for the business. When we started the company, as I said, we were intending to be a platform company, but based on a model that said we would design test samples and wafer scale validation samples for our customers, at which point we and they would go to outside fabrication houses to have the products made at scale and deployed in their various processes, depending on what the application was. We found about 5 years in that wasn't going to happen from an economic standpoint. So we set about developing our own proprietary production processes and procedures, which still needed to be demonstrated that they could be used at scale. And so when we came into 2021, our plan was to build out an HQ facility in Halifax, which is underway now, and to build and implement by the first half of next year pilot scale production at our own facilities that would allow us to do 0.5 meter roll-to-roll production of our nanoweb film in particular, and all of the high-speed production, high-volume production of the lenses that we talked about in AR. That was going to require about $10 million of CapEx, and we thought that we would start up very early in the first half next year. And you can see the image of the roll-to-roll type equipment that we're having built. Well, and then the plan called for us beyond the first half of next year to continue to grow these machines and in our own facility, and as we grew with our customers, to ultimately enable the customers to become self-sufficient in their own production. Well, we found a company in Canada, actually we've known about them for a while, that we ended up acquiring after our merger with Torchlight in the summer of 21. And what that merger brought to us was 2 things. First of all, it brought a new vertical. Nanotech Security is the name of the company, and they hold a very interesting position in the banknote security space. They're able to produce and supply covert and overt security features for banknotes. They're working with a number of the central banks around the world, and they have a very important contract with one of the top 10 central bank companies or businesses in the world, and they announced literally 2 days prior to our merger with them that they had renewed that contract going forward. In order to satisfy that contract, they needed to have scale production capability in place and ready to go. So in addition to the new vertical they brought with them, they also brought a number of skills and capabilities in design, in origination of masks that are needed for the lithography process, recombination of those things into large scale so we could produce, and a facility outside of in Thurso in Quebec. That's a 100,000 square foot facility. They're only using half of it right now. But that facility is totally secure for banknote purposes, and at the same time has capacity today to produce 7 million square meters of film per year. It can't produce our nanoweb yet, but it can be adapted quite readily to do that. And in the meantime, they can produce other films that we need for things like applications in solar and in some of the medical applications, as well, obviously, as the banknote security thing. So what this acquisition enabled us to do is in effect to leapfrog an expansion plan that we had and abbreviate it by a couple of 3 years. From a financial perspective, the company is still a startup. We had a lot of investment that we've made over the years. We came out of the third quarter of this year with about $140 million on the balance sheet. I would caution you that the 2 days after the third quarter closed was when we acquired Nanotech, and that was an all-cash deal that took about 70 million of that cash. We still have capacity under an ATM that we haven't taken as yet. It's 110 million, and we've been very, very good at getting government funding, especially from the government of Canada, and it tends to be non-dilutive funding. So we've managed over the course of this year to undergo a fundamental transformation of the company, both in its operations and in its financial condition, and we're not finished. So if I look at the company from an overview perspective, we are laden with multinational subject matter experts. We have a lot of very smart people in this company. We have a very broad and growing IP estate. We have software-driven simulation tools for our design processes. We have proprietary production and design platform that we use all the time. We have scalable and sustainable products. Sustainability is really important to us. We want to make sure that we can always, wherever it's possible, do more with less. We work very well in our global partnerships with both OEM and Fortune 500 companies. We are the first metamaterials company listed on NASDAQ with both a public listing and the scale to produce millions of square meters per year of this material. And we have routine access to non-dilutive government funding. And with that, I will end and take any questions there might be. I don't see any. Up sharing. Well, if there aren't any questions.
We do have one question in the Q&A box.
Let me look. Okay. Yeah, I'll answer this question live. So the question was, how much have we received in grants and when? I believe the number is a combination of grants and very low interest government loans, and I think the number is close to 50 million. We still have about 6 million on the balance sheet in 15-year interest-free debt, which is why we haven't paid it off, and that's the only debt we have. All right, I don't see any more questions. So I thank you all for your time, and I think I've come up right at the end of the time slot.
Terrific. Thank you very much.
Thank you. Take care.
Record.